session in the quantum algorithms in your this faculty development program. In that quantum algorithms, expert tools with the Shors and growers algorithms, which are basically very important in this quantum technology. So due to these shows and growers algorithm, it provides the exponential speed up, and it offers the exponential improvement in the every task, like the, for example, if you want to calculate the factorings of the large numbers, and if you want to search the unsorted database, at that time we can use these exponential speed up algorithms, just like the your Shor's algorithms and growers algorithms. So these Shor's and growers algorithms is presented by this quantum computing technology. Second important part is the just like the cryptography, as we know that the security is the important part in every applications in every platform. So day by day, every technology has a developing mode in developing nature. So when any technology is developed at that time, one important concept is the security. So security concerns is important. So these quantum computing break these classical encryption methods. As we know that in classical encryption techniques, which algorithms we have to use, just we know that every faculty members know that they're having the information security system is one of the subject to the our university students. So this information security system provides the RSA algorithms. These RSA algorithms is having some limitations. These limitations are overcome by using the cryptographic technique developed by the quantum cryptography. So quantum cryptography provides the QKD keys, QKD keys. That means quantum key distribution for the secure communications. Then another one thing is the optimizations. Then another one thing is the what we are discussing here. This drives the innovations in science, industry, and technology. So this quantum technology drives this in future in science, industry, and every technology. That means it handles the big data, quantum technology, quantum approaches, manages these big technologies, big data in future, and it gives the proper output related to this big data analytics. And another very important thing is we are on everybody on talking on the artificial intelligence. So this artificial intelligence is combined with this quantum computing can improve the this quantum computing itself improves the algorithms provided by the artificial intelligence, just like the neural networks, neural languages. These algorithms are improved by using this quantum technology. So this is the our brief introduction. After that we will discuss here the overview of the quantum computing. Already you know that the key concepts in that quantum computing, first key concept is the qubits. We know that the qubit is what? As we have told you that this qubit is just represented as represented by the 0 1 simultaneously, just like your classical computers. This is the basic unit of quantum information, analogous to classical bits, but it's having its own quantum properties. Just unlike the word bits 0 and 1 in classical computers, it having the qubit are exist in this your quantum computing. Next is the superposition. So this superposition is the fundamental principle where qubit can exist in the combinations of both 0 and 1 states at the same time. So it enables the qubits to exist in multiple stages at one time. That means it enables the parallel computation. Okay. So it enables the parallel computations as quantum system can process the multiple possibilities simultaneously. Okay. So upon these measurements, qubits are collapsed with these 0 and 1 probabilities. Then third state key element is the entanglement. It's the correlation between the qubits allowing the instantaneous state change. What is exactly meaning this? A quantum phenomenon where qubits become correlated such that states of one qubit is dependent on the state of the another qubit. Okay, so this entanglement shows that a quantum phenomenon. This entanglement shows what? It shows the quantum phenomenon where qubit becomes correlated such that state of one qubit is dependent on the state of the another one qubit. So here the distance of them between them we doesn't need to consider, or which doesn't need to concentrate on the distance between them. It only shows the phenomena where the qubits become correlated with one qubit is dependent on the state of the another qubit. So measurement of the one qubit instantly determines the state of the another, leading to the applications in quantum teleportation and quantum cryptography. It shows in this entanglement key concept. Next is the quantum gates. Now see here, quantum gates is what? It is the operation manipulating qubits to perform the quantum or perform the computations. So exactly what is meant by these quantum gates? Already your search other previous experts also told you that it's quantum gates. It gives the concept of the analogous to classical logic gates but operate on qubits using unitary operations. So unitary operations means reversible transformations. It shows the reversible transformators. So they're having the some common quantum gates. Okay, these quantum gates, just you have heard the name Hadamard gate, then Pauli gate, C0 gate, and Toffoli gate. So these quantum gates are presented here. So these quantum gates manipulates these qubits through the rotations on the Bloch sphere, making quantum computing uniquely powerful for parallelism and interface. So these are the different key concepts which we have discussed here. Now, next point is quantum applications. We will discuss these quantum applications. So, quantum applications, quantum computing has a transformative potential. Okay, now just see here, these applications are not existing today, but it some applications existing today and some will be occur in the next 3 to 4 years. So quantum computing has a transformative potential across the various fields due to its ability to solve the complex problems. These complex problems are solved more efficiently than the classical computers. So first, it includes the quantum simulations, simulating molecular structure and reactions in chemistry and material science. So first application here is the this quantum computing works with the quantum simulations and simulating these molecular structures and reactions in chemistry and material science. So quantum systems are inherently difficult for classical computers to simulate due to its exponential complexity. Okay. Now these quantum computers can naturally simulate quantum phenomena, making it ideal for first is the drugs discovery. Okay. So first is the drugs discovery. That means simulating these molecular interactions for faster pharmaceutical developments. So when we are applicate this quantum with the quantum simulations in the first field is the drugs discovery. That means simulating these molecular interactions for faster pharmaceutical developments. So this is the first fundamental field where this quantum computing is now in the application mode for is the drugs discovery. That means we are simulating these molecular interactions for faster pharmaceutical development. Second is the material science. That means modeling novel materials and chemical reactions in this quantum simulation itself. And next is the high energy physics. That means simulating these quantum field theories and fundamental practicals. Just we are giving here example that simulating the behavior of molecule like caffeine, which has too many quantum states for classical simulations. So it is applicable here, quantum simulations. Second, applications in cryptography. So quantum cryptography. Now this cryptography term is already used in their information security systems. We need to apply the cryptographies here when we are working, when we are talking about this crypto. Now they're having the various cryptos are available, cryptography techniques, cryptography algorithms are available. Just we have talked about the RSA algorithm. This RSA algorithm is specifically working with our classical computers. Classical computers are uses this RSA algorithm to apply the cryptography techniques. That means here we have created the encrypted data to available the security to provide the security to the our data. Okay. So quantum cryptography developing the secure communication protocols and breaking the traditional encryption techniques. How? Here, quantum key distribution is one of the technique. That means QKD. Quantum cryptography, quantum key distribution is one of the technique here, which is used in this application. So, for example, it provides the BBB84 protocol. Here, this cryptography, quantum cryptography uses the BBB84 protocol, which uses the qubits to create the unbreakable encryption keys. See here, this BB84 protocol is used to qubits to create the unbreakable encryption keys. So security is guaranteed by non-cloning theorem and entanglement, which prevent the overshootings. So here this cryptography technique is used. Another one is in this under the cryptography category called post-quantum cryptography. While quantum computers threaten classical encryptions, just like they were breaking of the your classical computers algorithm, RSA algorithm, at that time, they also enabled two new cryptographic methods based on the lattice problems and error correcting codes. So these error correcting codes are available here in this cryptography. Next is the 1 minute. Next is the optimization. Okay. So quantum optimization enhancing the logistics, supply chains, and complex decision making systems. So what is the exactly presented in this quantum optimization? You know that the optimization techniques, our all the projects are focuses on these optimizations. Our problem statements are focused on these optimizations. So classical optimization problems often face some problems just like the exponential complexity, making them efficient for the large data sets. Now, these classical optimization problems often faces the exponential problems. What they are, they didn't face the large complex data sets. Quantum algorithms, which we know that the Grover's algorithm, Shor's algorithms, they offer speed up this system. How? by providing the logistic and supply chain management. Okay, by providing this logistics and supply chain management. What is exactly meaning of this logistics and supply chain management? It optimizing the delivery route and inventory. Okay, so this optimization can be obtained by using this logistic and supply chain management. It optimizes the delivery and route inventory, so we can apply this optimization technique. Second is the portfolio optimization. So portfolio optimization is also important in managing the various financial assets for maximum returns. Third is the energy grid management in this optimization. So optimizing power distribution in smart grids is useful here. Then next is the machine learning enhancement. So this optimization section includes the machine learning, which enhances the clustering, then feature selections and training the efficiency. So through this, we can obtain the quantum optimization and we obtain the complex decision making system through this quantum computing. So another emerging quantum applications. Before that, another important quantum applications. First is the artificial intelligence. We speed up data of this classical and neural network training. So everybody knows that the artificial intelligence handles the various large data sets. It creates the different training models, and through this we will get the data. We will get the complex solutions. So this artificial intelligence is works with these quantum techniques. Then another one is the big data analytics. So this quantum also handles this big data analytics in different ways. That means it handles the vast data sets with improved efficiency. Then another one important thing which we required in just we are thinking the environmental aspects regarding these quantum techniques. So how this quantum computing is used in the environmental aspects, that means weather forecasting and climate modeling, these are now we needed. So simulating these atmospheric patterns for the better predictions. So this quantum computing is a long-term impacting on the civilizing fields. So every field is touched with these classical methods, and the classical methods fails. And now due to these quantum techniques are implemented, or quantum techniques are evolved. So these are the current applications of this quantum computing. Now, next point is the market trends. Okay, so what is the exactly market size and market trends regarding these quantum computing? Okay, so market size, as we know that from the last 30 to last 20 years, IT industry captures the very large markets of not only India, it captures the large markets of the whole world. So here, when we are thinking on the globally, the global quantum computing market is projected to grow from approximately 1.16 billion dollar. Okay, so this is the authenticated source where we have got this information that the market size, this global quantum computing market is projected to grow from approximately 1.16 million in 2022 to about to 12.62 billion dollar up to this to 2032, exhibiting a compound annual growth rate of 34.8% during this period. So it will shows the market trends of this quantum computing. So, which are the various key players in this quantum computing? This quantum market is exponential significant growth driven by advancement technology and increase the overall the investment in the overall world. So everyone want, every large companies, every multinational companies want to invest in this quantum technology. Now market growth, when we are thinking on these future business projects, that global quantum computing market will grow from this 1.16 million dollar in 2024 to the 12.16 billion dollars up to this 2032. So this market focuses, that means forecast this size increase from USD 1.3 billion dollar to the USD 5.3 billion dollar up to the 2022. So in early of this January, they're having the one searching information in my search. In January 2025, the quantum computing sector faced the significant stock market volatility. Okay, in just January 2025, this quantum computing sector faced the significant stock market volatility. So just one Novida CEO, Jason Hong, name of this Novida CEO is Jason Hong, stated that the practical quantum computers might be 15 to 30 years away, with the 20 years being a reasonable estimate. Okay, this is the perceptions by the CEO of the Nvidia. So these perspectives led to sharp declines in the stock prices of the several quantum computing companies. Which are these companies? Just like the Regity Computing, who are having 45% exponential growth, quantum computing instance, D-wave quantum computing. So due to this, investments are changed. Okay. So despite of these recent market fluctuations, the quantum computing sector continues to attract the investments from the government as well as from the various private sectors, private entities. So it provides the growing ecosystem of the global players in emerging to develop and commercialize the quantum technologies. So while this quantum computing market is poised for significant growth, recent event highlights in the every sector volatility and challenges in predicting timeline for practical quantum computing applications. So the investors, various stakeholders should remain informed about this technology advancement and market dynamics and navigate this evolving landscape. So these are the market trends related to this quantum technology. So already we have told you that the rigidity, encoding, D-waves, these are the various startups. They have invested in this quantum technology. And established companies also, IBM, Google, Microsoft, Honeywell, these are also invested here. So global investment in quantum technology startups reach a record high 2.35 billion in 2022, indicating strong investors' confidence in this sector having a potential. So every IT company, every other companies are attracted to this quantum technology. These figures highlight the rapid growth and significant in financial commitment in the quantum computing industry, underscoring its transformative potential across the various sectors. So this is the market trends related to this quantum technology. So this graph shows you that the market trends in this quantum technology, quantum computing. So these values are shown in the billion in USD. Now, future directions regarding this quantum computing. So, which are the various research methodologies, which are the various research techniques are included in this quantum computing? So, future directions related to this quantum technology. So, we'll discuss is future directions here. Sorry, 1 minute. One water. So, these future directions related to this because quantum computing, see here, quantum computing is not in existing now. They're having the various researches, everyone are going into the research for related to this quantum computing. So future directions of quantum computing are shaped by ongoing advancement technologies. We know that the having the some theoretical concepts, we are back to these theoretical concepts and increasing the industry interest related to these future directions related to these quantum technologies. So first we need to focus on the quantum hardware, this quantum machine learning algorithms. So integrating this quantum computing with AI for faster and more efficient learning models. So we need to develop the various algorithms related to these AI and various industries, AI related industries. Then next is the quantum communication. We develop this quantum communication. Then developing secure communication network to register and developing this quantum computing. Next future direction is the scalable quantum computer hardware. So exactly what is mean by this quantum computer hardware, which shows that the future directions related to this quantum computing. So hardware advancements are very much required because it shows the scalability of their technologies. So developing more qubits while maintaining coherences and minimizing the noise here at that time we require. That means scalability is improved with this quantum hardware. Error corrections as implementing fault tolerant and quantum computing using techniques like the surface code and other topology qubits. Through this, we can improve the scalability in quantum hardware. Then superconducting qubits and ion traps. So here we refining the existing qubit technologies for better stability and longer coherence times. Then room temperature quantum, it shows that the exploring technologies like nitrogen vacancies centers these diamonds. And what is meant by exactly quantum algorithms and software development in these future directions? First is the we need to develop the quantum optimization algorithms. So it shows that improving the algorithms which are already existed related to these quantum technologies. So first basic algorithm is Grover's algorithm. This Grover's algorithm having a capability to handle the complex situations, complex problems, but it doesn't show the scalability. So we need to show the scalability in these quantum algorithms. Then they're having the hybrid nature. Just we have shown here the integrating quantum computing with the AI. So hybrid nature, hybrid quantum classical computer algorithms are required. That means combining quantum systems with the classical framework such that the PKI is one of the example algorithms example here which combines the high quantum with the classical algorithms. Then various software toolkits are required to enhancing the programming languages. We require the various platforms just like the Quickskid, Cyric, and Pennylen. So these software toolkits shows the future direction research. Then quantum error correction and fault tolerance are also required here. That means developing the more efficient error correction codes and focuses on logical qubits, fault-tolerant architectures to enlarge or to enable the long-term computations. So these are the future directions related to the research. So this slide shows you the future directions related to the research. Now, next we shows the future directions related to the industry. So first is the pharmaceutical research, revolutionizing drug discovery and personalized medicines. So it focuses on the drug discovery and personalized medicines. So pharmaceutical and material science, which works with these quantum technologies to simulating the molecular structures for the drugs discovery. So it works with that means application, and this industry applications are work. This industry application shows their interest in this quantum computing technologies. So these quantum computing technologies are works with this pharmaceutical research. Pharmaceutical scientist gives their interest in the quantum technology due to the simulating molecular structure for the drugs discovery. Then advanced materials discovery, identifying the novel material for energy storage and electronics. So just we have given an example of the climate modeling using the quantum simulations for accurate climate predictions. These various industries, which not only private sectors but also government sectors are also involved in this quantum technology. They give their interest in this quantum technology to obtain the accurate predictions, to accurate information. Due to this accurate information, they are able to provide the proper directions. They are able to provide the give the proper directions. So just we have given example of this climate modeling using these quantum simulations, which provides the accurate climate predictions. Then some finance companies are also involved in this quantum technology. That means they provide the financial modeling, solving the complex risk assessment and portfolio optimization problems. These all problems are solved by using these quantum computing technology. So financial sector also gives their interest. Financial sector also shows that this quantum technology is very much important. It solves the complex risk assessment. It handles the portfolio optimization problems. It provides the risk analysis through the too much big data. That means these quantum algorithms are works on these big data sets and provides the risk analysis as compared with your classical computers. It shows the 99% accuracy related to the risk analysis, portfolio optimizations, and very much important thing is through these quantum computing technologies, this financial sector find out the fraud detections. Now everyone talking on these fraud detections. So these frauds can be detected through these various quantum computing technologies. So finance is also involved in this. So by using the advanced cryptography techniques, advancing post-quantum cryptography, quantum safe encryption techniques, these various fields are uses these quantum techniques or quantum technologies. Now, future directions related to the cross-domain integrations. So cross-domain integrations here, quantum computing in AI. Okay. So here what happens, quantum networking and communication is the another important part involved in this future cross-domain integrations. That means now we are using the internet. Internet is nothing but the network of networks. So where we can handle the client server communications. That means client sends the messages to the server, server gives the response to that particular client, and we'll get the information whatever data we want through this internet. Now quantum internet is generated. through these quantum computing cross-domain integrations. Quantum internet, secure communication via entanglement and quantum teleportations are implemented through this quantum internet. Quantum repeaters are involved, this enhancing the long distance quantum communications. Then enlargement distribution is involved. This enables the secure key sharing across the global networks. So it is implemented in this quantum networking communication. Now, there have the various standards. Quantum standards are also developed in developing stage. That means these develops the various frameworks for interoperability between the quantum systems. So these quantum standards are there in the developing stage, which develops their own frameworks for interoperability between these quantum systems. And these standards are implemented through the ethical applications. That means addressing the concerns about the breaking the classical cryptography and privacy risks. So this inter-domain integration is involved. Just we have given the example of this quantum using quantum systems for large-scale environmental modeling concepts, just like your climate change predictions. So my one friend is working on this climate change predictions research in their PhD. They have given me one topic that predicts the quantum climate by using this quantum technology climate predictions. It shows that the classical computers doesn't shows the total accuracy related to these climate change predictions, but these by minimizing the time it shows the better results through this quantum technology. Actually it is now in the research phase. He has working on this and it shows the results. It works on this research and it creates the one climate change prediction model by using this quantum technology. It can take the help of the AI algorithms here. It handles the various data through the various data AI techniques also. So due to this cross-domain integration, just we are mixing here the AI technologies with the quantum technologies and providing the better future outputs related to every models. Now, IoT and edge computer. So I everyone know that nowadays IoT plays the very important role. Now every no one know that the smart computing devices are involved in this IoT and edge computing technology. Now we are discussing previous slides that the internet quantum technology is used the quantum internet facilities, quantum internet techniques. But when we want to implement this with the edge computing and IoT in the short local area, at that time we synergize between the computing system with and next generation IoT frameworks. So here we want to work with this IoT and edge computing technologies. So edge computing technologies and this IoT related to this quantum computing shows. Sorry, hello. This inter cross domain, we are discussing here the cross domain integrations. So here IoT and these edge computing techniques are mixed with these what we are saying that these quantum technologies. So this quantum computing is used for this IoT security. So everybody know that the IoT projects are implemented by using the various IoT devices, and it shows it IoT devices and it shows it mix up the various advanced technologies. Nowadays, in these cross-domain integrations, this IoT uses this quantum computing technology for their securities. That means it uses the enhanced cryptography technology. Quantum resistance cryptography protocols can secure these IoT networks against the future threats. Here, they uses the QKD key algorithms, that means quantum key distributions, which is used to encrypt for the secure IoT devices and quantum post-quantum cryptography. As we have discussed in the previous slide, post-quantum cryptography, developing the quantum safe algorithms for the devices, and here also these Shor's algorithms are mixed with this IoT and edge computing. Now, quantum is used to accelerate this data processing related to this IoT and edge computing. So this quantum computing can handle the massive data sets generated by these IoT devices and provides the it and enable them to fast analysis or faster analysis mode. That means this quantum computing can handle the massive or large data sets generated by these IoT devices. Then it handles the real-time insights. Quantum algorithms can enhance the data aggregation and pattern recognition for the critical edge applications. Just like when we have uses this edge computing in the healthcare monitoring systems, then this IoT is and edge computing is used in the autonomous vehicles. At that time, this quantum technology gives the higher real-time insights to these domains. And important point is distributed data. So now in this distributed data, now everyone working on this distributed data systems nowadays. Federated learning is the another one AI technique which is used for handling the distributed data. So these quantum enhanced edge nodes, now in the distributed data, they're having the different nodes and data is stored on the different nodes. So these quantum enhanced edge nodes can process the local data efficiently before transmitting it to this cloud. So this is important. That means this edge IoT and edge computing. Why this IoT and edge computing is interacted with this quantum computing? Because quantum enhanced edge nodes can process the local data efficiently before transmitting it to the cloud. Now, optimization in IoT networks and quantum computing, so it reduces the resources also. Quantum optimization algorithms are used to optimize the resource allocations of these IoT devices. It provides the efficiency in energy, that means reducing the power consumptions by optimizing the IoT devices or IoT device operations. So, also one important thing here is it also manages the traffic generated by calculated in the network. So network traffic management is also involved here. Efficient routing and load balancing by using the various quantum computing techniques. Here it can handle the network traffics, and this quantum is mixed with the machine learning techniques, and quantum machine learning algorithms for these IoT and edge computing are developed. So it enhances this pattern recognitions. So quantum algorithms can improve the anomaly detections. Then it is used to detect the various, what we are saying, that the detection techniques and predictive maintenance, and smarter edge devices are generated by using these quantum technologies. Now, various challenges in quantum computing. So it's okay, it's new technology. It's new technology, but is having some challenges. First challenge is noise and coherence. Quantum limited accurate computations are available with this noise and decoherence techniques. Scalability is also important point here. That means it shows the scalability related to the hardware, related to the your quantum hardwares. So difficult to build a large, what we are saying that it's difficult to build the large quantum systems or called fault tolerant systems. So qubits lose their quantum state due to the interactions with the environment, and decoherences, quantum decoherences are created. So quality of the qubit, this is also one of the important challenge with maintaining the coherences and scalability. So building large scale quantum processes processors with millions of qubits is challenging due to the noise and physical constraints. So then cost and resource requirement, then error correction and fault tolerances. So quantum gates are prone to errors due to the noise and decoherences. So quantum error correction is important. Logical qubits are important. Then quantum research transistors and quantum algorithms. So we know that the Shor's and Crow's algorithms are very helpful to the every field, but it is in still limited advancements. Then these some tasks will perform better on classical computers due to this current hardware limitations of these quantum computing. So these Bohr's algorithms are not working with this some our some fields. Then programming complexity is also another one challenges, where programming languages like frameworks like Qiskit, Cyric is still in the developing stages. Okay, still in the developing stages. So these are also some challenges related to this quantum computing. Physical and engineering other challenges are also then quantum. Just we have discussed that. So high computing, high qubit requirements are also required here. That means useful quantum computation requiring millions of the qubits further beyond these capabilities, and it's not available here. Then proper enlargement and connectivity between qubit is difficult for the larger systems. So this is another one challenges. Then secure and cryptographic risk is also here in these quantum technologies. Then measuring and controlling challenges are also that means measurement disturbance in the quantum state also here, and some theoretical limitations here. So overall, the challenges is in the research focuses. Okay, so how to overcome the challenges? Overcoming the challenges, error corrections. So we need to advancements in the quantum error correcting codes. Then novel materials. We require the novel materials for this research. So research on materials is stable with qubits, collaborations. So partnership between the academia, industry, and governments is required to overcome the challenges. So when we are working on this quantum technology, when we are showing the interest in this quantum technology, at that time we need to create the collaborative nature between the academia. So academia people need to give in their interest. They want to give the research in this field. The industry and also government shows their interest in this quantum technology. Then and then only we can overcome these existing challenges in this quantum computing. So career opportunities in this quantum computing, career opportunities, that shows the we will show here categories: career opportunity, academic and research in and teaching career opportunities related to these quantum technologies, industry roles. Industry also wants these the quantum engineers, quantum technology engineers, quantum researchers for developing this technology, for implementing this quantum in the various fields. Quantum startups and entrepreneurships are also one of the opportunity who want to enter into this field. They have starts their startups. They have start the small scale companies and works on this. They become an entrepreneur through these quantum techniques. So academic career opportunity, just like the researchers, research roles in the quantum algorithms, hardware and material science, then teaching positions in the various university and institutes are available related to these quantum computing technologies. Focus areas, quantum error correction, fundamental quantum mechanics, hybrid classical quantum schemes. So these are the areas where the anyone become a teaching faculty members related to this, and they have developed their career in these quantum techniques. Now, industry career opportunities. So, in industry, quantum software engineer is one of the posts. Then, hardware developer for quantum processor is another one post. Application developers integrating quantum and classical system is another one post. So through these various positions, anyone can enter in this quantum technique industry, quantum computing industry. Then various employers, tech giants in IBL and Google companies, financial firms using quantum computers, quantum algorithms, healthcare and pharmaceutical companies will be started through these employers. So quantum computing startups, Nobel startups, this Rigetti's computing focuses on scalable computing processors. This is one of the standard company who focuses on the scalable quantum processors. IonQ, which this company focuses on the specialized in trapped ion quantum computers. DWave, which focuses on quantum analyzing, annealing for optimization problems. So these are some notable startups where quantum computing is used. Then opportunities, innovation in niche applications, leadership and entrepreneurial roles. These are the various roles available in this field. Now, next point is which are the various skills required and education is required to enter in this new upcoming area. First is the core knowledge. We require the core knowledge of the mathematics. Where we need to learn the linear algebra, probability. So these mathematics knowledge is required for the quantum computing engineers, quantum computing researchers. And another one important thing is the physics, because this quantum computing is totally basically based on this physics, quantum mechanics. Then computer science, you require the knowledge of the various algorithms, how to design and develop the algorithms, then various programming concepts, how to implement this algorithm by using the various programming platforms. These knowledges are required. Then programming languages, Qiskit is developed by this IBM. We require to learn this Qiskit. Then Cyrillic language, which is developed by this Google. We need to learn these languages. Then Keeper, PyQL, TensorFlow, and Quantum. These are the various languages we need to learn, and we become a master in these languages. Then and then only we will giving the opportunity. We will providing the opportunity in this quantum technology. Then global initiatives, government investments, US national quantum initiatives, US quantum flagship programs, quantum hub in China, India, and Canada. That means this quantum technology is in research mode, but everyone want to invest in this quantum technology. So in future, just like your IT hubs, these quantum hubs will be generated and it will be starting to generate in the China, India, and Canada. Then private sector partnerships between the opportunities and research labs, then venture capability funding for startups. These are the opportunities in the quantum computing. Then quantum computing communities where we can share our knowledge. So Q World networking and educational resources. This Q World provides the networking and educational resources in this quantum computing people. So everyone who want to enter in this era, they have to join this Q Worlds. Then quantum open source foundations. That means promoting the open source development. If you want to promote this open source development, you can join this quantum open source foundations. So benefits workshops and collaboration on the cutting edge projects. You can collaborate your knowledge in the cutting edge projects in these quantum technologies. Ethical consideration is also important. So potential misuse in breaking encryption, we need to concentrate on these ethical considerations, then ethical concerns in algorithm and decision making. And so these are the two challenges in the ethical considerations, and the solution is establishing ethical guidelines for development, promoting transparency and accountability, because we can take the accountability whatever we have developed it, and it is creates the social impacts here. Then road ahead is this anticipated breakthroughs, fault tolerance quantum computers, hybrid quantum classical systems, and its impacts are transformation of the industries, advancement in scientific discoveries. So here we have concluding it. So quantum computing is a transformative field with a vast potential. It provides significant opportunity in academia people, industry people, and entrepreneurships. So we need to take the action, invest a skill development, and explore this emerging domain. Okay. So today we'll stop here. Thank you. Thank you very much. Yes.
Thank you so much, sir. And participants, you can please post your questions. Yes, participants, and any question for Narayan, sir?